Hey everybody, welcome back to another video. It's Zach again, and I do Leetcode and tech videos on YouTube. So today I'm going to be showing you guys how to solve 103 binary tree zigzag level order traversal. It's a pretty popular question, medium difficulty, but once you understand how to tackle these type of questions, they become very easy to go ahead with. I'm going to be solving this one in C++, but if you guys want to see it in Java, Kotlin, Swift, Python, just let me know down in the comments and I'll go ahead and upload one of those videos for you guys. So first of all, we want to understand this question, what it's asking. So it wants us to return an array of the elements, of the values of the elements. So each level, it wants it to be a vector or a list, depending on the language, or an array, whatever you guys call it in whatever language you're using. For C++ is vector, so it wants each level in a vector, right? It just wants you to return a 2D array, 2D vector, with each level as its own vector. But the trick is that you want to flip the order of each of all the elements inside that vector, right? So there's actually two ways to do this. You can use built-in functions to go ahead, flip the vector, just construct them. That's the way that we're going to do it in a level order traversal. Or you can use a depth first search. So go ahead, in order, post order, pre-order, traversal, recursively, and then assign levels to each node, and then go ahead and return those either flipped or not. I'll be showing you guys how to do depth first search level order traversal. So what we're going to need to do for this is initialize a queue. So if you guys don't know how to do level order traversals, you want to go ahead and open up a queue. A queue is a FIFO type of data structure, so first in, first out. Let's go ahead and name this queue, just the letter Q, and then if our node is valid, our first root, we're going to go ahead and push it in to the queue. And you guys will see very quickly why FIFO is what we want, not LIFO. I don't know how you say it, but last in, first out, which goes by the name of a stack. The data structure that allows us to implement that is a stack. So what we're going to do is, while our queue isn't empty, that means while we still have nodes waiting to be processed, we don't want to exit out of the loop, right? So first of all, we want our holding vector, our overall, let's say one-dimensional vector if you must. And this is going to be holding vectors of integers. Let's name this our result vector, and then all the way at the bottom, we're going to go ahead and return result. And then inside every single loop, right, we want to initialize a new, let's say, level vector. So this vector is going to be holding our it's going to be holding each level, and then we'll go ahead and reverse it at the end or not. And so now also what we want to do is we want to find the width of our level. So that's just going to be q.size actually. And then we want to go each node in our level. We're going to go ahead and so how we want to know if it's flipped or not, we're going to go ahead and initialize a boolean flipped. We're going to go ahead and set that equals to false first, and then all the way after each loop we're going to go ahead and reset. Let's go first of all in order. We're going to take out one of the nodes the top node, right? We're gonna go ahead, take that out, name that cur node. It's equal to q dot front, right? That's gonna be our top node, and then we're going to take that and push that into our vector. And then we're going to go ahead and push back our cur node value. And then we want to go ahead and if the left node is valid, we want to go ahead and push that into our queue. Right, so that needs to get processed the next round as well. And if cur node right, we want to go ahead and push that one in as well. Okay, and then there we go. And then all the way at the end, after we flip it, we're going to go ahead, flip, do, check, etc. And then right here, we're going to go ahead and push our level vector into our result vector. Alright, so how we do that is we just do result.push back level. And so now, but now the tricky thing is, since we want it in zigzag level, we're gonna have to go and flip it. So if flip, if we want to flip it, we will go ahead and reverse it. And this is a built-in function in C++, but if you insist, it's very efficient. But if you insist, you can go ahead and implement a reversing function on your own, either recursive or iterative, whichever way. This one works perfectly fine though. And then we're gonna go ahead and negate our flip variable and return this at the end. This should work. Should go ahead and work. Tree node, push. I think, is it insert? 1 second. Oh, we're not going to be pushing Q, we're going to be pushing our root. What am I doing there? Alright. If flip, oh, let's just rename this flip. Bunch of tiny mistakes. Reversed. Is it reversed? Oh, it's reverse, yeah. Time limit exceeded. Oh, I see what I'm doing. So I keep processing the same node since we're not. We need to go ahead and pop off the current node. What am I doing? Once we store it in this variable right here, we can just go ahead and pop it off the queue. And there we go. We got it working. Low memory usage, but it's a bit slow. But yeah, if you guys have any more questions, let me know down in the comments, and peace.